So why do we go to all this trouble? Well, it's usually easy to understand that relationships are a convenient way to link from one table to another. For a customer, we can just get all the orders. Well, just as important, if not more so, is the idea that a relationship describes a rule, a constraint that I cannot violate. That I now must not have an order row for a customer that doesn't exist. The database will not let me add a new order row with a customer ID 388 if there is no customer ID 388 in the customer table. Now, I may say, but I'm just about to add that customer, but at that moment, the database would be no longer valid. It would no longer be internally consistent. And this is what's considered a referential constraint. It's a rule that applies between tables, where each table isn't just applying the rules of its own column definitions, but it's also cross-referencing the data in the customer table to make sure that this is or is not allowed. And if there isn't a customer ID 388, you would not be able to enter that row. So defining these rules will often imply a sequence in your database for creation of new content. That in this case, if I have a new customer and a new order for that customer, I must add the customer first before I can add the order for it. It would allow a customer without an order, but it won't allow an order for a non-existent customer. Now, the idea that data is not just valid within one particular row or one particular table, according to the rules of that table, but valid and meaningful between all your tables is known as referential integrity. And there's two places that it primarily has an impact. Adding new rows, as I just described, making sure we can't add an order row with a customer ID that doesn't exist. Now, this also applies for updates. I can't bypass it by adding a row for customer 369 who does exist and then changing that to a value that doesn't. It'll refuse that too. This is still referential integrity, enforcing the rules of the relationship. Now, what's more interesting is what happens with referential integrity when you delete something. So if our data currently exists between these two tables in a valid, meaningful state, say I have customer ID 367 who has two associated orders, well, what happens if I delete customer 367? Well, in most database systems, it depends. It depends on you and your rules and what you want to have happen. One option you have when deleting between tables that have relationships is something called a cascading delete. If I want to delete a row from the customer table, the database says, you're the boss, and will just immediately delete any related rows. So in this case, I tell it to delete customer 367. It will first cascade down and delete all the order rows for that customer and then delete the customer row. And if you have multiple tables connected to each other, one delete operation could theoretically delete many different connected rows in other tables. Another option for deleting is cascading nullify. Some database systems have this option, although it is rarely used, where you would null the foreign key column. So in this case, I delete customer ID 367, and the database would automatically scan all the orders, and where it finds 367, set that to null. So it's a situation where I must keep the order, but it's kind of now detached from a particular customer. It still exists, but with a null column. So what we're not doing is pointing to a customer that doesn't exist anymore. But more likely than either of these is simply refusal, no action. This is the default in most database management systems, that if you've created a relationship between these two tables, and then you try and delete a customer that has existing orders, it's not going to let you do that. It will refuse the delete option. So just as when creating new data, I'd first have to create the customer first, then the order. When deleting, you'd need to delete all the orders first or transfer their ownership to some other customer ID, and only then would I be allowed to delete that customer row.